Welcome to our next lesson on simple machines. So today we'll be talking about load, effort, mechanical advantage, velocity ratio. So what are these things all about? So our objective today is at the end of this lesson, students should be able to define load and effort, define mechanical advantage and state its formula, define velocity ratio and state its formula, simple and do simple calculations with velocity ratio and mechanical advantage. Now, a load is an output force overcome by the machine. Its symbol is L. Effort is the force applied to the machine. Its symbol is E. So if you look at the diagram, this is the load, and if you look at this, and this the effort applied. If you look at a physical diagram there, which you have this where the load is applied. This is where you apply the effort, sorry, not the load. You apply the effort, and now this is where the load is. So you apply the load there. So that's the force that will be overcome by the machine, and this is where the person or you watching the video apply a force. So that force applied by you is called the effort. Now, what is the mechanical advantage? Mechanical advantage is a ratio of load to effort. So its symbol is MA. Mathematically, MA equals load divided by effort, which the symbol is capital L for load and effort is capital E. And it has no unit. So when the mechanical advantage is greater than 1, it means that less effort is applied to carry a greater load. When mechanical advantage is less than 1, then the effort is greater than the load. So now we have a triangle here. This triangle helps us to always do calculations on mechanical advantage. If they have given us load and an effort, we can always get the mechanical advantage. So this line here stands for division, and this line here stands for multiplication. So if they've given you the effort and the mechanical advantage to look for load, means that your formula becomes mechanical advantage times the effort will be equal to the load. Now, equals to the load. Now, you have saying that this one stands for multiplication. So if you are looking for the load, it will be mechanical times effort. So if you are looking out for the effort, it will be load divided by mechanical advantage. Now, what is velocity ratio? Velocity ratio is the distance moved by the effort to the distance moved by the load. Its symbol is VR. So VR equals to distance moved by the effort divided by distance moved by the load. So it will symbolize distance moved by effort by dE and that moved by the load by dL. So velocity ratio has no unit. So this triangle this way is the same as that we use for mechanical advantage. So it's used to also do simple calculations on using velocity ratio and distance moved by effort and distance moved by the load. So if you have load, distance moved by load, and velocity ratio, you can be able to calculate what the distance moved by the effort by simple calculations as we did for mechanical advantage. Now let's do some calculations on using mechanical advantage and velocity ratio. Okay, question 1. A lever requires 50 newtons of effort to lift a 250 load. Calculate its mechanical advantage. So in any question, before you do it, you get to know what I've been giving you and what you're looking for. We are looking for mechanical advantage, and we have given effort, which is 50 newtons, and load, which is 250 newtons. So what is the formula that links mechanical advantage to load and effort? From our lecture, we know that mechanical advantage is equal to load divided by the effort. So it will be equal to 250 newtons divided by 50 newtons. So you will give an answer which is equal to what? 5. Our answer is like this. Has no unit because mechanical advantage has no unit. Okay, if that's understood, let's go to the next question. Question 2. The effort piston of a hydraulic jack moves a distance of 7 meters while lifting a load a distance of 0.35 meters. What is the jack's height velocity ratio? So the first thing you have given the equation, we said we should need to identify what have been given. So we have been given the distance moved by the load, which is 0.35 meters, and distance moved by effort, which is 7 meters. Now, what is the formula that relates distance moved by a load and distance moved by effort to velocity ratio? And we know velocity ratio equals to what? Distance moved by effort divided by distance moved by load, which equals to 7 meters divided by 0.35 meters, which gives you what? 20. So it has no unit, so we'll allow our answer like this. I hope it is understood. Good. Now you have watched the lecture. You have seen how you have done simple calculations on mechanical advantage and velocity ratio. Now summarize what you've seen and you've heard. Write them down and answer these questions by pressing the video.